So let's start. Sorry for the small delay in the beginning. Seems to be a lot of buttons up here. I hope you all recovered from yesterday evening. Maybe since this is the first presentation on this track, maybe we should take it a little bit easy. My name is Tom Lysmos. I'm from Promon, and today I'm going to mostly demonstrate, but also try to explain a little bit about the aspects of what you could say penetrative testing on the client side. So this is very much about the threats and the method used on a client system to do bad things. So let's try to think for 1 minute. What is it that we want to achieve today? Well, I would like to, hopefully we will learn a little bit about security in this presentation, but also I would like to, if we succeed, give you some methods for improving the economy for you and your better half. This is something that we shall see how you can achieve this also in this presentation. So I think if we succeed, it should be pretty good in the end. Okay, security. Typically when you hear penetration testing, this is about the server side, taking care of, if you have a web service, the security, identifying vulnerabilities at the server side. But unfortunately, maybe, there is also a client side to this web service scenario. So let's just have in mind, okay, we have a web service handling sensitive information. Well, quite often the security level at the server side is pretty well taken care of. We have some kind of encrypted communication, which often is quite good. But then we have this client side. It's about unmanaged PCs. It's about stuff that often is not really under control. So often we don't really know what's going on out there. And I think this is a little bit the things that has not been focused so much upon when it comes to security of web services. It's like, well, we can't do anything about it anyway if it's online banking and it's private end users accessing the bank web service. Well, you can't do anything about the client side, so let's forget it. But in this presentation, let's take a look on this client side, on the methods which can be used to do evil stuff. And since this is the client side and threats on the client side, I have to say that I would say that maybe 99% of the threats on the client side is really about Windows. So we better focus on Windows in this when it comes to this aspect. So here I have prepared a VMware image, and I have to say it's a nicely infected system, as you might see here. Here we have a nice keylogger. And actually, it's a PC of my wife. And I installed this keylogger to keep a little bit track on what she's doing. And this is something that I can highly recommend. So here we have the actual spy, quite widely used keylogger. So let's just dig straight into this. Okay, so we now have this infected system. So let's forget about how it became infected. Well, it was probably maybe some email attachment, whatever. There are many ways in, but let's forget about that. So the infection vector for the malware to gain access to the PC, let's forget it. Let's just assume that it's there. And in this case, it's quite a lot. So let's start. Let's see how it goes. So now I shoot up Internet Explorer. As you can see here, my wife is really a fan of toolbars. So when it comes to sensitive web services, actually we just saw the first bad thing when it comes to security. Actually, we can see that the browser in some sense has already been compromised. There's already some unknown stuff in there, these toolbars. And it might be very nice to have in many circumstances. If you do random surfing, great to have, great help. But when it comes to sensitive web services, well, it's not a good thing. But nevertheless, it's there. So let's just see. First, I activate the keylogger. I go back to the browser and just type a little hello world. Stop monitoring. And you can see here, the keystrokes were easily captured. Can you also see this in the back? Okay. Should I try zooming a little bit? Or is it okay? Okay. Okay, good. So, behind the scene, what actually happened here? Well, obviously the keylogger got the keystrokes. So how did he do that? Well, on Windows, like I would say about 90% of the keyloggers, he registered himself as some nice GUI event extension module. He used a standard API, set Windows hook. Some of you might be familiar with that. So this is a standard Windows API, so there's nothing about exploiting a buffer overflow vulnerability inside the browser to gain access. Well, not at all. This is just a standard Windows API. The keylogger registers himself as such a thing, and the operating system happily grabs the keylogger module, puts it into the browser, and hooks him up to the keyboard interface from the inside. So, okay, this was listening to the keyboard interface, but it was happening from inside the browser. So right now, the keylogger module would be inside the browser, hooked up to the keyboard interface in a very, very standard way. Thank God, you might think that this kind of method could never be used on my PC because I have my installed antivirus. He may or may not recognize the keylogger as malware, but one thing is pretty certain, and that is, if you don't, the keylogger would have free play. There are all kinds of also legal programs doing this, so your typical antivirus would not react to this at all. And maybe when you think about client-side security, you might think, oh no, this presentation would be about the millions and millions of Trojans, variants out there. So now when I shoot up the Promon TestSuite, you might expect a lot of buttons. One for this, 1,000 buttons for this Trojan, how he can get access to the browser. But as we shall see shortly, our test tool doesn't have a lot of buttons. And how come? Well, if you look at it from the antivirus perspective, the appearance of the malware, then it's true. Then it's about millions and millions, small variations in the looks and the appearance. But when it comes to the method, if you look at a very active bank troll like Seuss, you would see that there are millions of variations out there rapidly changing themselves. But when it comes to the method, the actions taking place in the client side, well, there's actually only one. So all these variants, well, they all do the same. Use the same 2, 3 methods, like everybody else. So when we forget about the appearance and focus on the action, well, all these variations really boils down to some key things. But before we leave the keylogger aspect, let's just use the tool now. First, I select the application to attack. I enable the keylogger. And again, hello again. The keylogger easily grabbed. So for keylogging, there are really two aspects to consider there. One was this interface inside the browser. The other one, in this case, our test tool is listening to this interface from the outside. When it comes to sensitive web services, there are really two important aspects of the browser security, so to say. One, as we saw, are the interfaces. Another important thing is, of course, what kind of thing you allow to go into the browser. And now let's do a man in the browser attack. So let's first look on some injection vectors which can be used to gain access to the browser. And then let's look at the consequences afterwards. So first, I perform a code injection. And as you can see, boom, I have a nice devil pulsating inside the browser. What I did here was again set Windows hook. The operating system injected my devil DLL. And of course he would, in a real case scenario, he would start operating in the background, making a pretty boring live demo out of it. So we added this pulsating devil. Also on Windows you have a very convenient way of also gaining access to another program by means of manipulating the execution flow, in this case inside the browser. So I do a code execution attack, and again the result is the same. So what happened now? Well, the attack tool now created a thread of execution inside the browser, and again it was a standard API, create remote thread, for those of you who know that. What happens then is the attacking tool simply tells the operating system, can you be so nice to create a new thread of execution inside this process? And the operating system happily does that. You get your own stack, it starts executing after a while, and boom, you have your devil inside. So, just give me 1 minute here. So these first two illustrations were about gaining access to the browser. So let's see a little bit what can we do when we have the access to the browser. What are the consequences? So here we have, again, a man in the browser attack tool. My wife, as you can see, would try to log into her Google Gmail. So when configuring this tool, first I have to gain access to the browser, which we already saw, and then I need to do some configuration in order to be able to steal things. So if I now quickly take a look at the source of this page, I can scroll down a little bit, and somewhere down here I would find the name and the ID of the two elements that I'm interested in, and it would be about here. Here it's email. I cheated a little bit, prepared myself in advance, and here it's password. So now I got the ID of these two elements,